Awesome. Thank you so much, Prashant, for joining us from IE University. Today, we'll be going through data analytics, and he'll be going through what, why, and how, along with career paths within data and analytics. Passing it over to you, Prashant.
Okay. So Shweta, do you mind allowing me to share the screen? Yeah, it's good now.
Okay, awesome. Yeah.
Okay. So thank you everybody for coming to my presentation, and thanks TOHacks for the opportunity to share my thoughts on data analytics and how one can build a career, not necessarily a job, on in this particular field. So before I go further, I would ask Alia, who is from the IE team, to share a few things about the university, about our amazing place.
Thank you, Prashant. Hi, everybody. My name is Aliyah Somani. I work with IE University. I am based in Toronto, so I think a lot of you are probably in the Toronto area. So just a quick snapshot about IE. We are a very international university. We offer undergrad programs, master degrees as well. We're quite focused on business management programs, technology, and marketing programs as well. We are a very, we're not your typical university. We do things in a more innovative and hands-on learning methodology. So we're quite focused on tech, innovation, entrepreneurship, diversity. We have over 160 nationalities on campus, and all our programs are taught in English. We are based in Madrid, but I am a local contact. So if any of this piques your interest, I'll pop our email address in the chat, and feel free to reach out. And Prashant is one of our faculty at IE, so I'm going to hand it over to you.
Thanks, Aliyah. So coming to Aliyah's note about being an international university, yes, it's truly international. And this university is based in Spain, and Aliyah is in Toronto, and I'm speaking from Calgary. And I teach at IE. I travel twice a year. Next month, I'll be in IE for a month, and again in November for a month. So I can easily say that it's one of the most international or most diverse places, not just in nationalities, but even in terms of thinking and new ideas. I'm always challenged when I stand in front of my students, and it is always, I feel nervous, like talking to them. Okay, so this is me. Like I'm a consultant, professor, author, and a professor. I bring over 25 years of data analytics experience. I work for big companies such as SAP, Shell, Apple, and GE and P&G. But at the same time, I work for many small startups as well. The problem has been the same in all this, whether it's a big company or a startup. How do we get value out of data and analytics? So what can we do to improve the performance of the company using data and analytics? I've trained over 3,000 people in data and analytics, including quite a few from IE. I've written 2 books, which you can see right behind me, Data for Business Performance and Analytics Best Practices. The Analytics Best Practices, incidentally, has been ranked as #1 best analytics books of all time recently by Book Authority. Apart from my consulting and teaching pursuits, I am an advisor for Evalueserve in Switzerland, Griosoft and Miles in India, and UARO in Singapore. They are all data analytics company in the different stages of the data lifecycle. They play a role. I'm a blogger, of course, a professor at IE, and I have a PhD from ESE Lille in France and MBA from Kellogg School of Management. So what do we have today? So I just want to give all of you a quick introduction about data and analytics. We have many definitions of data and analytics, so I just want to share my perspective. Then we look at the components of data and analytics. And lastly, careers, and I'm open for your questions and feedback as well as ideas. So let's look at the definition of data analytics. So I see almost like 15 people in the room. So if somebody were to ask you, what's your definition of data analytics? What do you think is all about data analytics? Why so many companies in the world are talking about data analytics? From Justin Trudeau to the business heads of companies, everybody's talking about it. What is that data analytics? How would you define it? Type your answers in the chat box. Would love to hear your definitions. Studying data. Good, Monica. That's good. What else? How data works for us. Okay, good. Interpreting data. I'll take one last one before I share my thoughts. Good one, Patrick. Sandeep, understanding the patterns. Love the two keywords in Sandeep's definition. Patterns and decision making. Love it. Okay. So there are many definitions. Okay. Brad, insights, predictive, prescriptive. Very good. Okay. So there are many definitions of data and analytics. In fact, today, every company is a data company. Like, for example, recently, Canada's one of Canada's biggest banks, Scotiabank CEO, Brian Potter, said that we are not a bank, we are a data company. So you can see that the importance of data even in a bank. So overall, whether you are an accountant, whether you are an engineer, whether you are a teacher, whether you are a physiotherapist, or whether you are a doctor, physician, everybody is using data and analytics for improved business results. But there are many definitions. Even in the chat, we saw that there are quite a few definitions of data and analytics. And things become more complicated when you get into the real world. Why? Because everybody is coming up with their own perspectives. It is almost like six blind men looking at the elephant and starting to describe elephants in their own words. For instance, if you talk to people in finance, all said and done is primarily a regulatory function. They are looking at financial reports, whether it's compliance to IFRS, GAAP, and all those things. They are looking at regulatory compliance as well. So their definition of analytics is more towards reporting historically. If you look at supply chain, their definition of analytics is more towards customer service. Now here comes the technology companies. If you talk to SAP, I worked in SAP for a long time, and SAP's definition of analytics is pretty broad because they sell over 200 different products from ERP to CRM to GRC to BIW and so on and so forth. So their definition of analytics is pretty much broad. But on the other hand, if you talk to Tableau, which was recently acquired by Salesforce, their definition of analytics is pretty much on dashboarding, on visualization. Yeah. So if you look at the functions, if you look at the technology companies, and on top of it, if you look at the industry as well, their definition of analytics is also very different. If you talk to companies in the oil and gas, their definition of analytics is more towards regulations, mainly on data. Whereas if you talk to financial services and retail companies, or even the media companies, their definition of analytics is both data and insights. So there are so many definitions of analytics. So with such complexity in the definition of analytics, my definition of analytics is pretty much simple. I leverage what Sandeep just said, where I said analytics is basically using data by asking questions to gain insights for decision making. Sandeep calls it as patterns, I call it as insights. Why are we doing analytics? The whole ultimate goal of analytics is about decision making. That's the end game. How do we make better decisions using data and analytics? So as you know, I'm a professor at IE, I'm an adjunct professor, I'm also a consultant. So when I talk to my clients, they think, what's analytics? Oh, we need Python, we need R, we need Tableau and all those things. I said, true, you need all those things, but you don't need them in the beginning. What you need to start is what are the questions for which you are seeking insights for? Next, number two, do you have data to get those answers? So bottom line, whether you are a finance person, whether you are supply chain, whether you are HR, whether you are in oil and gas or banking or utilities, whether you are in tech or non-tech, one common definition of analytics is using data to ask questions to gain insights for decision making. Remember, the goal of analytics is better decision making. That's the ultimate goal of analytics. So there are different types of analytics. So I call it as analytics continuum or a conversation. Broadly, you can look at analytics as three major buckets. Descriptive, which is what happened, which is on the historical performance. Predictive, what will happen, which is on the future performance. And prescriptive, which is what Brad was talking about, what will make a particular event to happen. Let me give a simple example about how these three things work. We have Bob, who is the data scientist in a company, and we have Nancy, who is the CFO. Nancy goes to Bob and says, hey, Bob, how much revenue did we make in 2019? So Bob says, this is what happened, or Bob thinks, this is what happened, descriptive analytics, historical performance. So let me go to my ERP system and pull out the data for Nancy. He goes to Nancy and says, hey, Nancy, for the year 2019, we made $350 million. Nancy says, thank you very much, Brad. Assuming that the conditions remain the same in 2023, can you tell me how much revenue we will make in 2023? So Bob thinks this is what will happen. This is predictive analytics. He goes back to his desk, does some regression models, and comes back to Nancy and says, hey, Nancy, for 2023, we are going to make $375 million. Nancy looks disappointed. Nancy tells Brad, hey, Bob, can you tell me what are those factors which will help me get $400 million? Because the CEO has told me the target for the company is $400 million. Can you tell me the factors which will make it happen, make the company get $400 million? So Bob goes back to his desk. He does some prescriptive analytics models, linear programming, simplex, what if analysis, scenario planning, and all those things. He comes back to Nancy and says, Nancy, if we have to get $400 million, there are two factors that will make it happen. Number one, increase the SKUs or the products in the company, the stock keeping units. Next, number two, manage the payment terms, that the money which we are collecting from our vendors and the money which we are paying for, collecting from our customers and the money which we pay for our vendors when they provide their services to us. So this is how the conversation is actually happening between Bob and Nancy. This is not a siloed conversation. It is a continuous conversation that is happening between the inside producer, who is Bob, and the inside consumer, who is Nancy. Generally, in the companies, we do all of this together simultaneously because it's about inside consumption and inside generation. It's not something that we do descriptive analytics with dashboards and Tableau and we are done. As soon as we are done with this, just like Nancy was asking, tell me what's going to happen in the future. So all said and done, descriptive analytics is about the past and predictive and prescriptive analytics is about the future. For example, I go to Shweta and say, hey, Shweta, I got an amazing dashboard which I built in Power BI, which is all about the daily temperature of the year. From the first day of the year to the last day of the year, I have the temperatures, highs and lows, humidity, precipitation, name it, you have it. It's in a stunning dashboard. The visuals are amazing. The data is perfect. Data is accurate. No questions asked. But this is the data for 2016. I give Shweta one more data point, which is just a scribbled note in Post-it. And I give it to Shweta and says, hey, Shweta, this is the day high and the chances of rain this weekend in Toronto, in Vancouver. She's in Vancouver and I'm going to tell her. Just one liner, scribbled with my in my handwritten Post-it. The day high in Vancouver on Saturday is going to be 23 degrees centigrade and the chances of rain is 40%. Which is more valuable, the one which is in the future or the 2016 data, which is perfect? Of course, she would value the future. Why? Because she can plan her next course of action. What can she do with the 2016 data? Nothing much. She can just look at it and just do some analysis. Whereas even the data, even though let's assume that the data which I'm giving it to her is 60% accurate. In predictive analytics, we call it as R-square in regression, for instance. Even if the data is 60% accurate, that is even better than the 100% accurate data which she has in 2016. So bottom line, the future of analytics is in predictive and prescriptive. When we say predictive, the analyst-driven ones like what you sit and do with regression, or even machine learning, for instance. This is all about the future, where we are planning the organizations for the future. That is why companies are more interested in predictive and prescriptive analytics and less on descriptive analytics. So what is this insight? Insight is that unknown factor, if known, would influence my decision. I don't have this information now, but if I had this information, I would have made a better decision. What is that? For instance, I moved from India to Canada in 2009. And if somebody had told me that in 2009, Prashant, instead of buying a house in Calgary, why don't you buy a house in Vancouver? I would have become a millionaire, right? But today I had to work even on the weekends because I didn't have that insight in 2009 to make the decision of buying a property in Vancouver. So if I had known this, I would have made a better decision. So bottom line, these two insights can be of two types. One is somebody can tell me, Prashant, the property prices in Vancouver is going to go up. And next, number two, I need to act on that. Once is the one, not just knowing, but even acting up on that insight. So I call this as two major types of insights. One is the performance insights or KPIs. Next is actionable insights or KPIs. Performance insights basically provide information about the visibility to the decision maker. Like, for example, I want to know the top 5 customers by sales, top 5 spend categories. I want to know what's the recurring revenue I've been making every month, so on and so forth. But when you have this information, it gives you a choice, either to know or to act. So if I just know, for knowing and I just keep it, it becomes theory. But if I want to act upon it, I get something called as actionable insights. So what is that actionable insights? Actionable insights are the insights that are based on performance insights that can be acted upon by the decision maker. And when we talk about the decision maker acting upon this actionable insights, there are two major factors. One is decision, and to make a decision, you need consumption of resources. For instance, if I decide to buy a property in Vancouver, I need the money, that resource, to make it happen. So actionable insights are dependent on two factors. One is the decision or the leadership. Next, number two, whether do you have the resources to make it happen. And the common thread for both decision and consumption of resources is those factors which are under your influence and control. So not just looking at actionable insights, whether you can act upon this or not. So just to give you an information, just to give you an example here, I was working on a fuel retailer, which is the biggest fuel retailer in North America. They have gas stations in Canada, in US, and Caribbean. So we came up with this report which says that all the SKUs, the stock keeping units in your company, can be categorized into 4 categories, A, B, C, and D. And we have a report now which says that in the last 12 weeks, the last 15 weeks, these were the 10 items which were consistently marked as category D. Okay, so we shared this information to the territory managers, and everybody was very excited with this information. So they all came, almost like 30 to 40 of them came to this meeting, and we presented this. These are the 10 SKUs which were consistently marked as category D, which is basically the D are slow moving items. So these territory managers don't want to keep items in the shelf which are slow moving. They want fast moving items. As soon as you keep it, it gets sold. So we presented this on the screen, and everybody said, this is amazing. We have been asking this for months and years, but nobody provided this. Thank you very much, team, for providing this. Okay, so you have this list, the 10 items which are consistently coming as Class D items. So what next? You need to convert this into decisions. So I told them, I'm not a territory manager, but my common sense says that you need to stop keeping these items in the shelves. They said, hold on, you can't go like this. Why? Because we all have signed multi-year contracts with these vendors to keep on supplying these items as long as this contract is active. So if you want to discontinue this item from the shelf, you have to go back to the contract, terminate them, and give the penalty to the vendors, whatever it is, and then we can do this happen. They said, okay, this is a great suggestion, but sorry, we can't do it. So what is the story here? You had great insight, the performance insights, but they are not actionable, at least for now. So what companies need is not just about knowing, but also insights which can be acted upon. And how do you make this happen? So it's basically you need the combination of science, which I also call it as common sense. Next, number 2, data and analytics. Walmart did a study, and they said during the time of hurricane warnings, people buy essentials, milk, water, eggs, and so on and so forth. Of course, it's a science proven. It's also common science. We need essential items during the crisis. Of course, during the COVID times, people also started buying toilet paper. That's a different story. But what Walmart did was they looked at their data and they said, hey, our data says that people are also buying strawberry Pop-Tarts during the time of this crisis. Oh my gosh, this is completely counterintuitive. Why would somebody buy a dessert during the time of the crisis? You need essential items. So all said and done, most of the time people buy items which are kind of irrational in nature. But regardless, to get holistic insights, you need your science and data, both of them, to come together. So I wrote an article in Forbes which says that for holistic machine learning, you need to integrate both science and data. so that your machine learning models are reliable. So after this session, if you are interested, you can Google my name and this article in Google and read this article if you are interested. Bottom line, from those you get insights, which are the two types of insights which we discussed earlier. So why are these companies talking about insights? Why do we need insights? MIT did a study and they said that 26% data-driven companies are 26% more profitable than their peers. McKinsey did a study that if you do data analytics, you are going to acquire customers 23 times more, 19 times more profitable. Your profit increases, so on and so forth. Boston Consulting Group, which is one of a big consulting company, every year they come up with the 50 most innovative companies in the world. And today, if you look at the top 10, 9 out of the top 10 are in the data and digital companies. Forrester did a study and they said this is a growth. And if you look at the top 5 companies in the world today in terms of market capitalization, it's all data-centric companies. If you just look at 2 of those top 5 companies, which is, for example, if you look at Apple, for instance, the market capitalization of Apple is even less than some of the huge countries in the world, like Saudi Arabia, Mexico, and all those companies. So this is going to be a huge factor when it comes to getting business value. So from productivity, from bottom line, from growth, from market capitalization, name a metric, the data-centric companies are there. Even it's not just about the Facebooks and the Ubers and the Netflix of the world, which are into data and analytics. Scotiabank, John Deere, Good Life Fitness, Real Madrid, politicians, everybody is using data and analytics to be better in what they're doing. So so there is increased value in what data and analytics have been employed by the companies. So how do you make this happen, Prashant? So there are 4 key components in data and analytics. Before we go there, let's look at what data and analytics is all about. So in many places, they equate data analytics to data science. That's okay, but it's only a small part of it. So I look at data analytics as 4 major components. First thing is about digitization, where you capture the data so that you have a process which is converted into data. But in most companies, the data is not there in one system, in one format. It has to be integrated. In fact, data integration is a majority of the work in data analytics. In fact, 70 to 80% of the work in data analytics project, which I do, is about data integration, bringing data from that system, this system, all those things, creating the data pipelines, cleaning the data, and ultimately putting the data into the data warehouse. So that's a huge amount of work. And once the data is there in the data warehouse, which is one standard system to do your analytics, you run your data science models, which is incidentally a very small effort, but it has got a lot of attention these days. So data science, like regression, all those things, for example, if you have good quality data, you spend very little time in deriving the insights. Okay, good. Now, once you derive the insights, what are you deriving the insights for? So Sandeep said about decision making. That's exactly what we are doing. Convert those insights into decisions, because if you're not able to convert those insights into decisions, it is practically a performance insight. You're not making it actionable. You're not making those insights actionable. So what is the link? So you have the APIs and the data pipelines, which link the data capture to integration. We have the data warehouse and the semantic layer. The SL is the semantic layer, which links the data integration to data science. And then you have the payoff table, which is all the benefits which you have by doing this decision, which links the data science and the decision science field. And the bottom line for all those things is KPIs. So remember, this slide says that data analytics is not data science. Data analytics is much more than data science. Data science is one small component of data and analytics. So what are the key components, Prashant? So there are 4 key components when it comes to deriving insights from data and analytics. The first one is, of course, data. You need data to derive insights. Great. How do you derive insights? Of course, this data has to be put into the engine, and that engine is called as algorithms. It could be as simple as arithmetic mean, where you add 2 numbers and divide it by 2, you get an arithmetic mean. Of course, it is also a model, or it could be a little bit complex, where you have this regression, for instance, or else you have a more complex model, which could be an ensemble model, where I take multiple models and mix it all together and come up with an insight. Bottom line, they are all algorithms, which are the engines which take the data and churn out insights. But at the same time, often there are some assumptions which you need to make to run your algorithms. Oh my gosh, what are you talking about? Assumptions? We thought data and analytics is all about black and white. You take data, and run some statistical models, and you get insights. What is the assumptions to doing here? Most often, the data, or well, not most often, data is always a recording of the past event. But most often, companies don't have the complete data. Why? Because businesses is an evolving entity. Why, Prashant? Why is it an evolving entity? Because things change. Why? Because of mergers and acquisitions, divestitures, new product introduction, pandemics, COVID, monkeypox, you name it, the business is always in a state of flux. So to manage that state of flux, the data is not available readily, so you need to manage it with assumptions, with getting data from other places, talking to your experts, using your common sense, whatever it is, make sure that the assumptions that are applied are kind of real. And once the insights are there, you are making sure that the insights are applied in a very ethical way. So today we are talking about the world of ESG and net zero and ethics and all those things. So along with ethics, we are also talking about AI ethics, because AI is going to play a big role in the way businesses are run in the next few years. So we want the insights that have been churned out by the models in an ethical way. So let's look at the business data. So businesses capture data for three main reasons: for operations, compliance, and for decision making. But often it is for operations and compliance, they're capturing the data, which could be in a structured format, which could be in an unstructured, which could be based on integration, security, and so on. But that data per se in the native state has got little utility for analytics. What analytics teams need is data in these three formats. Either the data type can be nominal, it can be ordinal, or it can be continuous. Nominal data is all about text and categories. Ordinal data is all about ranks and orders, and continuous data is all about numerical entities. Of course, if the values are numeric in nature, I can do statistical computations and derive more insights out of it. But the main challenge is transforming the data from the left side, which is the native state, into the process side, which is for the analytics, which is on the right side. But if you don't, many companies don't do this, and they capture the data in its native state, and often it becomes a big issue in terms of cost, risk, compliance, and so on and so forth. So I wrote an article in Forbes which says that the default state of data is a liability. Many people say data is oil, data is oxygen, blood, and all those things, which is good. Provide that is only applicable if you know how to manage it. If you don't know how to manage it and just keep the data in your database, data actually becomes a liability. That you can read it after this presentation. You can go to Forbes and again search for this. But we will stick to the topic, which is about analytics. For analytics purposes, to derive insights, you need data in these three formats. So nominal, which is about text, ordinal, ranks, and interval and ratio, which is about numeric data. Why, Prashant? Why do you need these three data types? Because your data science models depend on the data type. And of course, it depends on the questions and depends on the assumptions which you are making. I will take a simple example and talk about the techniques which you have learned in your high school. One of the data science models which I have is median and mean. So you know when to apply median and when to apply mean. If there are outliers in the data set, I'm not going to apply arithmetic mean. Instead, if I'm going to apply median. If the data points are independent in nature, and if I have to consider all the data points, I'm going to apply arithmetic mean. So who is going to decide this? So this is basically dependent on the assumptions which you are making. The assumptions here is that if you are going to say there are outliers because this business process is not consistent, then I'm going to rely on median and not on arithmetic mean. But on the other hand, you say, hey guys, this is not an outlier. This is a standard business process. Include all the data for your analysis. Then I'm going to use arithmetic mean. So the data science model, whether you're going to select mean or median, is based on the assumption whether they are going to be outliers or not. Now let's come to the question, for example. Let's go back to our example of Nancy and Bob. Nancy goes to Bob and says, hey, Bob, how much money are we going to make in 2023? So Bob looks at Nancy's question and he says, how much? That means the data type is going to be numeric in nature. So that when I go back to Nancy, she is expecting a numeric answer from me. So I'm going to apply linear regression. So and he goes to Nancy and he says the number is $375 million. So Nancy asks Bob, Bob, will it be a profit or not? Will we make a profit or not? So Bob says, now Nancy is going to ask a categorical question. Profit or loss? The category is only two types, profit and loss. So the linear regression will not work. So I'm going to use logistic regression. So the point, if you go back to the previous slide, this picture, I've not made this PPT or this slide just to talk about from the theoretical aspects, because these data types are dependent, will have an impact on the data science models which you are going to select. Overall, the data science models, whether you're talking about a simple one like median or mode, or whether you're talking about regression, or whether you're talking about an ensemble model, they are basically dependent on the questions, data type, and the assumptions which you are going to make. The algorithms, as I said before, three types of analytics. These algorithms could come from exploratory, associative, the inferential, predictive analytics, which could be analyst-driven predictive analytics or machine learning. It could be prescriptive, which could be an optimization or sensitivity analysis or scenario planning, whatever. And all the insights which you're going to get are put on the reports and dashboards. Assumptions, as most of you know, it's something which is considered true without much proof. Of course, it has to be realistic as well. And probability is one of the ways to quantify the assumptions. Wherever you are having this probability, there is some assumptions which you are going to make. If you're taking some sample data and making inferences with the hypothesis testing and extrapolating the whole insights to the population, you have something called as the p-value. We talk about p-value. If it is less than 0.05, reject the null hypothesis, blah, blah, blue, all those things, which again is based on assumptions. If you run the regression model and you saw the p-value less than 0.05, you are going to say, I'm going to use this independent variable in my regression model. That's where assumptions also come into the picture. So wherever there is assumption, there is probability. And wherever there is probability, there is something called as p-value, which you are using especially in predictive and prescriptive analytics. Why predictive and prescriptive analytics have this p-value? Because there is probability that is associated with this. And this probability is the one which is going to affect your insights generated. So how long should we wait, Prashant? Do you expect this 100? Should we make everything as assumptions, or should we wait for 100% quality data? There is nothing called as 100% quality data. It doesn't exist, because in the business world, things are actually changing. Probably in the academic world, in the theoretical world, it exists. In the real world, there is nothing called as 100% quality data. So for decision making, they say that 40-70 rule. What is that? Do not start your analytics project if you have less than 40% data. And if you have more than and if you have up to 70% data, it's good enough. Don't wait for data which is more than 70%, because you run into law of diminishing returns. So 40-70 rule should be good enough for decision making. And there's a lot of articles which say that they say 75% is what you need for decision making. Today, we are not talking about big data per se. We are talking about right data. We are not talking about volumes. We are talking about quality. So we are talking about right data now. The industry has also matured now in that way. And AI also says it's using the right data and so on and so forth. Ethics. The last part of having making sure the analytics are good is having the right ethics, making sure that the data is sensitive. That means it's secure. You should be able to explain it in the right way. There is no biases in the insights that have been derived. Data engineering is done in a most ethical way and is the most up-to-date data that has been available, and make sure that the insights that has been derived are able to satisfy your stakeholders well. So these are at a high level, the main components of data analytics. Now let's see how you guys, if you are trying to pursue and looking at pursuing a career in data and analytics, what can you do? So let's talk about the careers in data analytics. So first I will talk about my careers in data analytics. So I started in my first job in 1996 in India. I worked for an engineering company before I started, before I moved to Belgium, where I joined Procter & Gamble. So at that time, I also started my part-time PhD in a local university in Belgium. Then I moved back to India for family reasons, and I joined GE. And GE was a place where I started to learn about data and analytics. So what we call as data and analytics today, GE call it as Lean Six Sigma. So pretty much what I have been teaching, learning, and all those things has got a big bearing on what I learned in GE. And on top of it, we didn't do all those projects just for the sake of generating insights. We try to apply those insights in the real setup as well. So I got to know more about how to apply those insights to a real world problem. So overall, GE played a big role in my career development in the field of data and analytics. Then from India, I moved to Canada in 2009. Then I started my own company in 2012. And when I started my PhD in 2000, I got it in 2013. You can see that probably I would have done a world record here to get a PhD degree almost 13, 14 years. And then I published my first book, which is for data for business performance, which you can see here. And that gave me a lot of credibility in the market. When I wrote a book, a lot of clients started saying, oh, this guy has written a book. Let's talk to him and see what and hear what he has got to say. Then I got my executive MBA from Kellogg. Then in 2019, I started working as an adjunct professor with IE University. And in 2020, during the year of COVID, I published my second book, which is the Analytics Best Practices, which is right now ranked #1 in the world as the best analytics book. So that was my career journey, and this is what people are saying about the demand for data and analytics. Whether you are in Canada, whether worldwide, analytics is the #1 skill to have. So that's what World Economic Forum says, and that's what I see it as well. Every job is going to be centered around data and analytics. So that means whether you are an accountant, whether you're a teacher, physician, engineer, whatever role you are playing, you are going to need data skills to excel in your job. It is as good as a communication skill. Just like you need communication skills to excel in your job, you also need data skills to excel in your job. So having said this, I'm going to put a short video about some of the misconceptions people have in the industry about data and analytics. I'm going to paste this in the Zoom chat. Have a look at it, and once you are done, type done in the chat box. Okay, I'll wait for one more done. Alia is also done. Okay, let me go back to my PPT. Where is it? Okay, it's here. Okay, now you must be wondering, how do I start? How do I get into this field? Okay, so here is my plan. The first thing is think big. Have a very big goal. Don't be restricted. Don't restrict yourself to smaller things and all those things. First thing is think big. Next, number 2, start small. What does this mean? So there is an amazing book which I would suggest everybody to read it or even buy it. It's called Atomic Habits. So in this book, the author, James Clear, he says the power of tiny gains. What does this mean? So let's say that you have taken my course. Let's assume you join IE and you have taken my course in data analytics. And when you finish my course, I give you a score of 100 out of 100. Good. Now you have a plan. Of course, you need to start building your knowledge, because it's not the knowledge doesn't, it's not nothing like stocks kind of thing. You need to keep on acquiring. You need to use it, because if you don't use it, you will lose it. So now today I give you 100 points, 100 of 100. Very good. So you make a plan. That means every day I'm going to improve by 1%. So today 1%, tomorrow again 1%. So every day you keep on improving. So next year, same day on May 25th, you will be 37 times more than where you are standing today. That means 3,700% more than what you are today. That's case A. Now case B. So you decide not to apply what you have learned. And every day your knowledge capability reduces by 1%. You lose 1% today, tomorrow 1%, so on and so forth. So next year at the same time, you will be just about 3% where you are today. So it's about making a plan and working on it. Everything happens in an incremental basis. So having a plan and doing it bit by bit. You can't bite an elephant in one bite. You have to make it into small chunks and plan it and work on it. So this is about the power of tiny gains. Think big, start small. So this more on this in that book. This is an amazing book. It's just about $10. I would suggest everybody to even buy it. It's not worth it. It's just like a price of one Starbucks coffee, almost like that. So it's an amazing book to keep it. The third one, which is my personal advice, is to write your goals down, not think about it. They say people with no goals and people with goals. If you don't have a goal, and if you have a goals that is written down, you are 30 times more successful than having no goals at all, or even 20 times more successful than people who have just goals in their head, who are just thinking about, I need to do this, I need to do this. So execute well. How do you execute well? By having a goal that is written down. You can even stick it in your desk or whatever it is, and reviewing it constantly. So this is what you need to have. Think big, start small, and execute well. So specifically, what does this mean, Prashant? The first thing is get a good overview of this data analytics. So there are many courses which people can take. If people are part of the IE MBA program, they take my course, which is about 20 hours. So I also created a free course in Udemy, or I think it's almost free. You can do that. But if you want a more formal course, there is almost like a 3 to 4 months course in Johns Hopkins, which is called Data Science Specialization. It is very cheap course. The only requirement for that is severe amount of discipline. Discipline is required to pursue this course. So if you have a budget which is about $300, $400, and if you are able to commit almost like 3 to 4 months time for this, this is an amazing program to have. It's a 10-course module. To do it, I would strongly suggest you to do this. Next, number 2, pick up a programming language. It could be R, Python, whatever, even Excel for that matter. Pick a tool and master this. But more than that, you should be knowing how to apply them. One is about knowing the tools, the techniques, and all those things. Next, number 2 is about applying them. For example, if I give one tool, say for instance, a hammer, for example, and ask you to use it, what you will do, you are going to use it for everything, even for cutting an apple, for example. But to cut an apple, you need a different tool, like a knife. So you need to know which tool is applicable where. Sometimes Excel is also good enough if you want to show the world that this is what these are the capabilities of data analytics. Sometimes you want to do a lot of number crunching. So in that case, R or Python might be better than Excel. But Excel can do a lot of things as well. Or if you want to do more about prescriptive analytics, which what Brad was talking about earlier, you can do a more sophisticated tools from SPSS, SAS, and all those things. But more than anything else, learn a tool and apply it. Know how to apply it, not just about knowing it. It's about knowing where to apply, when to apply, and when not to apply as well. The third thing is Stay relevant, stay in the knowledge pool. So today we are all fortunate that we can get access to experts in social media. Like I'm big in LinkedIn, but I do a little bit of Twitter as well, but mostly I'm active in LinkedIn. You would say if you are in LinkedIn, for example, you can follow some experts, whoever it is, whether if you want to learn more about regression, if you want to learn more about data management or Snowflake or Tableau, all those things, you can connect to those people or even follow them and so be up to date about what's happening. And lastly, about networking. In my view, networking is not about taking. It's not you send a mail to somebody and say, hey, do you have a job for me? That's not networking. It's about giving. What is it you're willing to give so that you can make the community better? So they say your network is your net worth. So it's about, these are the 4 steps which I have for you guys. One is to build the skill. Next is work on the skill and make it relevant. Know where to apply it. Stay in this pool of knowledge, because if you're not motivated enough, you might lose the track. So to be close to those people who are talking this day in and day out, so that you are not out of touch with the subject, the topics, and so on. And finally, network. It could be LinkedIn. It could be going to the Event Hub conferences. TOHacks is organizing something, wherever it is. Network and network with people and share. So that's it from me. So this is the book which I was talking about, the 100 best analytics book of all time. My book is at #1 now. So if you need the copy of this box, you can go to my publisher's website and use this discount code, which you'll get 25% discount code on this 2 box. I'll just pause for about 10 seconds for you to take a screenshot of this page. If you want to buy it, you can go there and apply this promotion codes and get 25% discount. So I think that's end of the presentation for me. So I'm here for your questions, feedback, or anything. But before I leave you guys, so these are the key takeaways. Analytics is all about questioning and using data to get answers for those questions. No questions, no data, there is no analytics. Stop your projects right now and try to find out those questions for which you are seeking insights for. R, Python, regression, ensemble models, all those things, they come later. The first thing which you need is about questions for which you're trying to seek insights. And majority of the projects in data analytics in the industry are actually failing. And one of the reasons is not just because they can't afford to buy Power BI. It's not that they don't know where to download the latest packages from R or Python. It's because of poor education or poor data literacy, of course, the culture as well. We talked about the 3 types of analytics: descriptive, what happened; predictive, what will happen; and prescriptive, what are the factors that will cause a particular event to happen. And we saw intuition, insights, or patterns, which I believe Sandeep was talking about, can be derived both with intuition and data. And to derive those insights from data analytics, you need data, algorithms, assumptions, and ethics. So I'm here for your questions, thoughts, and ideas. Thank you very much, TOHacks, for the opportunities and opportunity, and thank you all for coming. I will stop sharing here, and this is one of my favorite quotes. I worked in GE before I joined SAP, and this was GE at that time when Jack Welch was there, was one of the amazing places to work. And this is one of my favorite quotes. It's not just about generating insights. Transforming those insights into action is the ultimate competitive advantage. So this is my email ID, and I'm active in LinkedIn, so you can connect with me in LinkedIn as well. Choice is yours. But I'll be here for the next few minutes to answer your questions on anything, on data analytics, career, whatever you want.
Awesome. Thank you so much, Prashant, for that great presentation on data analytics. I see a question in the chat. I think you were just talking about poor data culture on your last slide. So someone asked, what is good data culture and what are signs of good quality data?
Okay. Well, great question, Brad. I'll take your first part and then I'll go to the next part, which is about good quality data. So the data culture, it's a very tough question. Great question, a very tough question to answer. So right now I'm doing a course for CFOs who are primarily from Dubai, on Middle East. So this exact question which Brad is asking, they also asked me in the class. Well, how do you build a data culture? So in that, I had some thoughts. They also had some ideas and everything. So what we discussed in that course was basically, number one, building a good data culture requires 3 key elements. Of course, for people who are just out of the university, it might look a little bit philosophical or theoretical, but people who are in the industry might appreciate this more. The first thing is you have to build a culture of serving somebody, which is about treating everybody in your organization as a customer. And that service mentality should be there. Because why service mentality? Because when you want to serve somebody, you need to be consistent in your service. And what is the reference point for that service? Consistency coming from? That comes from data. Because you refer to the data to create a baseline, to create a reference point and everything because your service has to rely on something. So that's number one. Next, number two, I would say is about a culture of continuous performance improvement. So I was talking to a VP of an oil company, and he said, Prashant, you have been talking a lot about data and analytics. Can data analytics help me get more oil from the ground? So I said, no. To get oil from the ground, you need a pump jack. But to look at the performance of the pump jack, you need data analytics. So indirectly, you need data analytics to get more oil from the ground, but not directly. So if you believe in a system of continuous performance improvement, so that's where data analytics comes into the picture. If you don't believe in performance improvement and you say, okay, this is what things are, I'm just going with my tribal knowledge, the hierarchies and all those things, then you don't really need data and analytics. And the third one is about related to the second one, which is about culture of consensus-based decision making, not hierarchical. If you say, I'm a VP and you need to take it because I believe it's the right thing to do, then data analytics will not work. We'll just come to you and say, hey, well, what should we do now? We'll just follow your advice. But if you believe that like for example, the Walmart's case, Walmart said that, okay, common sense says that people buy milk, water, and eggs, but out of the blue, you say that people are also buying strawberry Pop-Tarts. Oh my gosh, where did you get this insight from? From data. So I would say to Brad, to your point is about these three things to not only those three things. These are three main things. There could be many more depending on the companies, but I would say these are the three main things. So I'll take the second question as well, which is also very good quality data. So in my first book, I talked about 12 key dimensions of data quality, which is about accuracy, completeness, security, and everything. But it doesn't mean that all the 12 dimensions are relevant all the time. It's basically data quality is contextual in nature. It depends at this point in time, what is important for me. What does data quality basically mean? So in that way, what I would say is the data quality, how to make this happen is structuring the data. 80% of the data which we capture in the company is unstructured, which is text, voice, video, and images. How do we label it so that we can query the data so that we can get good insights? That's number one. Next, number two is about capturing the data just for purpose. If the data that has been captured is used for compliance, decision making, and regulations, that means it's an indicator that we have good quality data. And then, of course, it can help help in decision making. That's what I would say is the science. What you asked is science of good quality data. Yeah. Again, both are very good questions, but both require. That's where consultants make a living. I would say. So, Patrick, would you recommend students to stay away from career in data science because of work being automated? Oh, great questions once again, Patrick. Which is what I said in the thing. But at the same time, I would not say stay away from data science. Every company is going to be a data company. So data has to be integral to the work which you are doing. Whether you are marketing, whether you are in sales, whether you are in HR, you can't ignore data. You need to have data skills, just like your communication skills. Well, whichever role you are performing, even whether you're a student, you need to be good in communication. So I won't say that stay away from data science. That's like the extreme case. Of course, I would never do that because every company is going to become a data company. So what I would say is integrate the data science skills or data analytics skills into your job. That's what I would say. Whether you are a HR manager or an engineer, data has to be integral to your job. Monica, being new in career, what types of projects should we have in our portfolio to be considered for data analyst positions? Let me think over. So, Monica, at a high level, what I would say is talk about those projects which talk about an impact to the business. Think about, so what? Say, for example, today I say, hey, Monica, come, I want to do I want your help to for a data analytics project, and you work with me for 6 months. Okay, you finish a project and you have done a lot of work in Python. You have cleansed the data with Talent, and you have interacted with so many clients and everything. Think about, so what? What impact did this project made to my clients, to my stakeholders? So when you talk about what types of projects, I would go a step back and think about the projects and the impact to the business your projects have been making. Whether it could be as simple as descriptive analytics, predictive, prescriptive, even data cleansing or sorting out data, whatever it is. There are many roles in data analytics, right? It doesn't mean that you always have to be a data scientist to do work on data. You could be even a marketing person working for Tableau. You could be a content developer for a company like AdScale, for instance. So there are so many opportunities which are there. But always think about one thing, which is the impact of your work. What difference did you make to your client? So we have a methodology in our company where we say to do data analytics project, we do a 3-phase project. What? That means what is the problem which we are trying to solve using data analytics? So what? That what is the impact of this? Why should we solve this problem? And next, number 3, now what? Now, how do we solve this problem, which is about the solution? So I would go to your point, Monica, I would say second point, which is about the impact. Look at your impact your projects are making. So every project has got a business case, right? But think about why this project needs to be done. Sandeep, as we discussed, for data, we make assumptions techniques, not all completely available. Can some automatic process be developed so that by looking at the data can be taken or applied? Yes. Say, for example, if you look at the machine learning models, for example, Google, Amazon, or even Whole Foods, they're all looking at kind of making some assumptions and deriving insights. There's a lot of stories how Whole Foods, which is an Amazon subsidiary now, has messed up with their ML models about all the recommendations and so on and so forth. So can some of the things be completely automated? I don't think it can be completely automated because things are always in a constant change of flux. The automation only works if you are able to build consistency in the rules. So automation and rule consistencies are highly correlated. If you can define something clearly, then you can automate it. But many times you can't define some things very clearly. So that means you need manual intervention as well. So some of it can be automated, some of it cannot be automated. So Bill Gates made a statement, to Sandeep's point, automation applied to an efficient process brings efficiency. Automation applied to an inefficient process is chaos. So you can apply automation to some, you can't apply it to all, but yeah, that's what I would say. But so it's all done. Yeah, it's all good. Great questions from all of you.
Awesome. Well, thank you so much, Prashant. As Prashant mentioned, if you have any further questions for him, feel free to reach out to him on LinkedIn. And I did capture a screenshot of the discount code, so I will make sure to post that in our Discord.
Perfect. Okay. Thanks to Shweta and TOHacks team for the opportunity, and thanks Aliyah for the opportunity to present my thoughts on behalf of IE to the team. And take care and stay safe.
Thank you, Prashant and IE University.
Thanks.
Yeah.